Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, we're going to be dealing with unsteady flow and DSS data. So what's going to happen is we'll run a simple unsteady flow simulation using flow data that's manually entered, and then later run the same simulation by reading in the flow data from a DSS file. All right, let's go ahead and get started. We've got HEC RAS up on the screen here. And as with all the exercises, we're going to be starting from scratch. So start by going File, New Project, and then navigate to the directory you want to save the project files in. And then give that project a name or a title. I'm going to call this Exercise 11, but you can call your project whatever you want there. And then make sure to click OK here to accept the US customary units. All right, so what I want to do first is open up the geometric data editor if you haven't already. Click on River Reach and then single left click to start and continue adding points to the river reach in the direction of the flow. Finish that up with a double click and then give the river and reach a name. So we'll say River A, Reach 1, and OK. Next, click the cross section button here because we're going to add some cross sections. Options, add new cross section. We'll start at river station 0. This is going to be at the bottom of the reach. And we're going to enter station and elevation data right here, which will define the cross section of the reach at that river station 0. So to do that, I'll say 0, 90, 100, 60, 300, and then back up to 90. All right, and then the overbank distance is going to start at 0 because this is the cross section at the bottom of the reach. I'm going to say 0.05 for Manning's N, and then the left and right overbank will be at stations 300 and 700. Okay, I'm going to click the Apply Data button. We now have a preview of that cross section over here on the right. I'm going to add another cross section at the top of the reach and then add some intermediate cross sections by interpolation. Then we'll get on with that flow data. So options, copy current cross section. I'm going to put this at 100,000 and then click OK. A couple things I need to do here is add some length to the downstream reach lengths. So I'll just make it the same for all three parts. And then I also want to increase the elevation. So adjust elevations. I'll say a 200-foot increase. So that would result in a slope of 0.2%. Okay, apply data. And then let me close this. I have my river station 0 and river station 100,000. So that's about 19 miles away if it's in feet. All right, next up to add some intermediate cross sections, I'll say within the reach. And then what I'm going to type in here is 10,000. That would give me, 9 intermediate cross sections. So interpolate and then close. All right, looks good. Next, I'm going to save this geometry file. I'm just going to go File, Save Geometry Data. I'm going to call this Base, and then click OK. And then head over to Edit Unsteady Flow Data. All right, so this is where I set the boundary conditions, initial conditions, and so on. Starting at the downstream reach here, I'm going to say normal depth is controlled by the slope of 0.002. Okay, so that's 0.2%. And then if I click here on the upstream cross section, I'm going to select flow hydrograph. This is the point where we need to determine if this flow hydrograph data at the upstream most cross section of the reach will be read in from DSS file or manually entered right here in this dialog box. So for this exercise, we're going to do both. The first, we're going to enter the data manually, and then we're going to return for a separate flow data file and then read that data in from a DSS file path. Okay, so first I'll select enter table, and I'll also say use simulation time. So that means it'll be set within the simulation data in just a bit. I'm going to go with the time interval of 1 hour, and this is going to be a 3-day simulation. So the data is down here, and let me just go ahead and grab some data I have prepared in Excel. Here is an Excel file. I have hours, and then I have flow data. So let me just copy this, Control C. And then if I highlight just a few records and Control V, it's only going to paste in the cells that I highlight. So with it still on my clipboard, I believe it's 72 hours or 73 records. It should be right about here, but I'm going to highlight a few extra cells just to test it. Control V and that looks good. So I'll show you the plot here. It starts at 200,000 CFS. The flow rate increases to 500,000 CFS right here after 12 hours, and then it slowly decreases back down to 200,000 CFS after almost 2 days. So if I click the plot data button, you can see that hydrograph. It's not exactly a natural looking hydrograph, it's more synthetic, but it's a steep slope up to a peak and then back down, and then another day or so of just a constant flow. All right, so let's close that. And I'm not going to enter any of this data down here. That's fine. I'm going to click OK. And then what I'm going to do is go File, Save the Unsteady Flow Data. And then for the title, I'm going to call this Manual Entry, because the other title we're going to use is going to relate to a DSS data entry. So I'll click OK. Let's see, initial conditions. I'm just going to let the boundary conditions control that. And I think we should be good there. All right, so file, save, close. All right, next up, we need to create the plan and then run the simulation. So we'll go run unsteady flow analysis, the base geometry, the manual entry for the flow data. That's good. So I'm going to go ahead and file, save that plan. The title is going to be manual entry. I'll click OK. And then manual entry here for the short ID. Programs to run, I'm going to select geometry preprocessor, unsteady flow simulation, and post processor. And then down below that, I need to specify the simulation start and end date and time. So I'm just going to make things easy and say it's 3 days at the beginning of January 2030. So way out into the future, at least at the time of this recording. And I'll start it at 0 hours for both the start and the end, actually. So I need to change this 1 to a 4 because the simulation is 72 hours in duration. As far as the computational settings, I like what I'm seeing here for 1 minute and 1 hour, and then the exported DSS file is right here. All right, everything looks good. I'm going to click compute, and that appears successful. So I'm going to click close now. Now we're going to look at some of the results, such as the water surface profile. I'm going to click on view water surface profile. Now keep in mind the slope is exaggerated. It's only 0.2%, but it looks a lot steeper in this diagram right here. Let's run the animation. That would probably be good. But what you're seeing here in this first checkbox for profiles is the max water surface elevation, and it appears to be pretty much a constant depth. There doesn't seem to be much attenuation in the peak flow. So if I go to options and then animate, I'm going to go ahead and make sure the speed is fairly high. That looks good. This is going to be 72 or 73 time steps. So let's just go ahead and run it by clicking the play button. And as you can see, the water rises quickly and then recedes slowly and then stays constant. All right, that's good. All right, let's go ahead and take a look at some numbers now. I'm going to close this and go view profile summary table. All right, what we have here is options profiles. So we're looking at the last hour. Let me take that off, double click max water surface elevation, and then click OK. So we have the total flow rate right here. Let me make this column a little bit wider. So 500,000, almost 500,000. This right here is the channel invert. This is the water surface elevation. Of course, that difference would be the depth. And I'm somewhat curious in the depth. So let's go ahead and remove these columns from critical water surface over and then just add depth. So I'm going to go options, define table, critical water surface elevation, delete column, delete all these. And then what I want to add is depth. So I believe it's max channel depth, but I could search right here and just say depth. That should help filter out the fields or the available variables. Here it is, max channel depth. So we'll double click and then click OK. So the channel depth, basically the maximum channel depth from the upstream station is 57.41, and it decreases to 57.21 at the end of the reach. So very little decrease in depth or peak stage, really. As far as peak flow, it looks like there's an attenuation from 499,000 to 494,000 associated with that maximum water surface. I'm going to go ahead and save this table so I can reference it later. Save table. I'm going to call this standard 1 plus depth, even though I did delete a number of columns. This is fine for now. Next, what I want to do is run the same simulation and look at the results, but instead of a manual entry for that flow data, I want to create that hydrograph, that flow data, external to HEC-RAS, read it in via a DSS file, specify the path, and then rerun the simulation, just so we have experience with both manual and DSS file input for our flow data. So let me close this. I'm going to return back to Edit, Unsteady Flow Data. Now, the first thing I'm going to do is File, Save Unsteady Flow Data as, and instead of manual entry, I'll just type in DSS, and then I'll click OK. Okay, so what I'm going to do now for flow hydrograph is click on this radio button and then reference a DSS file and then a path within that DSS file. So I'm going to use this top option instead. We need to prepare that file and path now. So what we're going to do is transition for a moment over into DSS view. So I have that saved on my computer. It's just another HEC software, which is great, by the way. I'd recommend learning DSS view before any other HEC software. And I will also leave a link in the description of this video to my playlist of videos to help you learn HEC DSS view. First video is a quick one that just shows you how to download and install. So if you're not familiar with DSS view, what you're seeing here might be a little bit quick. And so just roll with me on it. So what we're going to do here is File, create a new DSS file, navigate to the directory we want to save that DSS file in. This DSS file you're seeing right here is for the output of this HEC-RAS model. And I want to create a new one. I'm just going to call it data. So it'll be data.dss. And thank you. It's right here. There's a tab representing that file. And down here is the list of paths. Now we don't have any paths now, and that's why we have an empty table. All right, we're going to go ahead and create a manual entry time series. So this dialog box assists in that purpose. All right, so for part A, I'm going to just call that river, whatever river it is. I'm just being generic though. For part B, I'll say river station 100,000. Part C is the variable that's going to be flow. Part E over here is the time interval, and 1 hour is correct. Now, for the start and end date time, we want it to be the same as the simulation. That's really important. Otherwise, it won't work. So I'm going to type in January 2030, and then the start time at 0 hours. The units will be in CFS, and then let's see, instantaneous value is correct. And then I believe it says 31 December 29, but I believe 29 is the year 2029. Okay, pretty sure that's the case. I'm going to go ahead and grab that data from Excel just by copying it again, right click, paste. There's also a paste button right here. We can view the plot to confirm that looks good and save and no. All right, we can go back and double check our data here. It goes down 72 hours. Yep, so this is the 73rd record, which is effectively the first hour of day 4, if we're considering this the first hour of day 1. All right, let's go ahead and minimize this and now go back to our HEC-RAS. We're in our flow data for unsteady flow, and now we want to click this select DSS file and path. So what we have selected up here is the exercise 11.dss file. This is the DSS file for the current project, but this is data that's been exported as part of results. We don't want that. We want to read in the hydrograph that we just edited. So I'm going to click this button to remove that file. I don't have to remove the file, but I don't need it anyway, and I can add it later. Click the button above that to add a DSS file. Navigate to the file we want, which is this one here, data.dss. Now down below, we have the list of paths in that DSS file. And this is the path we want. It's the only path there is. And click OK. All right, so we have the file that's been loaded in and the path. That should be good. The time steps match up by starting on Jan 1, 2030. Everything else should be fine. Let me go ahead and save that unsteady flow data and close. All right, let's create a new plan for DSS data and then run it and take a look at the results. So run unsteady flow analysis. Now we're using the same base geometry, but this time the DSS unsteady flow file. So that looks good. file, save the plan. I'll call this DSS. Okay, DSS. And everything else looks good. Again, we're starting on Jan 1 at 2030. So let's click compute and see what happens here. All right, so that's running. All right, looks good. I'll click close, and then let's go ahead and take a look at some of those results. View water surface profile. If this looks similar to what we saw during the manual entry, then it should. This should be the exact same data, actually. Let's go ahead and run the animation real quick. Okay. And then let's take a look at the data itself. View, profile, summary table. And then let's see here. This profile is actually, okay, this is the first profile. This is the very beginning. Let me turn that off. Let's go max profile again and click OK. And sure enough, we have the exact same data as before. The max depth is 57.41. At the top of the river reach, river station 100,000, and then at the bottom of the river reach, river station 0, we have a max water surface, max channel depth, of 57.21. All right, well, that was a quick exercise on unsteady flow, specifically detailing how to feed HEC RAS, the hydraulic data that we want, both using manual entry and then also using a DSS file reference.